Hi, this is Discrete Math Section 5.6. We're going to be dealing with binary trees, traversals, post-order listings, and reverse post notation. Now, it sounds like a lot, and it isn't that bad. So what happens is that a computer uses different language than humans do to sort things out. So if I give you a problem to solve with the order of operations, a computer can't sort that out quite the way we can. So to develop consistency, they've done pre-order, post-order, order listings, and Polish notation, reverse Polish notation, different things to make it consistent for a computer to read. And so that's what we're going to do, is understand a little bit of what's going on in a computer language. So the first thing that we got to do is talk about binary trees. Binary tree is a rooted tree where each vertex has at most 2 children. So if I look at this, binary, yes, it has 2 branches. This would be what we call a parent, and then each one of these would be called a child or offspring. Now here's a parent, and then here are the children. Parent, children. Each one of these has at most 2 children. And so G here we end up with. Now the end of the trees would be just the G here, the L, K, J, H, and I. With those, well, we'll come to this, what we're going to try to do. So for instance here, parent A has children B and C. And then you can even write parent B has children D and E, and so on. And so that's how we can structure the order of this. A binary tree, that's what we have there. Rooted tree means that we're going to start with A, and it's just going to start off with that solo value right there. Now some other things, we have levels on here. So we want to describe the levels here too. This one right here going across would be level 0. And so we're going to start off with level 0. That would just be my A value. Now if we go down 1 generation, then that would be another level. So we have level 1. And then level 2 would be D, E, F, and G. So you can describe these levels just making sure that the root that you start off with has a level 0, and then we just go sequentially after that. So level 3 would be this last one here, and then these would just be blank because they are blank. Okay, so those are the different levels. Let's get into the nitty-gritty of some of this. We want to use a binary tree to represent a mathematical equation. So a binary tree is like that. And so what we want to do is take this thing and represent it with a binary tree. Now we do know the order of operation. Many of you know this as PEMDAS, or some of you, a student taught me GEMS. Grouping, exponents, and then you do multiplication, division, and then subtraction, addition at the end. So what we want to do is we want to start off our binary tree with the last used operation. So the last operation goes first. So what does that mean for us in this equation right here? Well, if I look at this, I have addition, but this is in a grouping. I have times 8 minus 4 divided by 2. So in this reference, the last thing that we would do is the addition and subtraction. So right now, that little minus there would be the first thing that we'd be looking at. So we want to start off our binary tree with a multiplication symbol. So with this, the subtraction symbol. What happens then is that any operation that we do have will be part of these different branches. Then at the very end, the end leaves will be strictly numbers. That's what this is going to look like. But right now I want to separate it over this thing. So I got 4 plus 6, and then I got times 8, and then I got 4 divided by 2. So those are the different pieces that I do have. Now I'm going to go on to step 2. And in step 2, I'm going to split this one up. Which operation would you do last between these two? Well, you do the multiplication last because this is a grouping. So what I'm going to do is I'm going to start this all over again. That minus is this minus. And then I'm going to have the multiplication symbol here. And then what am I multiplying? Well, I'm multiplying 4 plus 6 with the 8. And then here I'm going to do division. And the division is 4 divided by 2, and in that order. So what happens is that I'm almost done. My goal was to get numbers at the end of all these leaves, but I just have the 4 and the 6 that I still have to deal with. So I need to do this one more time. So I'm going to start off at the top, multiplication, division. Now you want to split these two up. Well, this is an 8. I want to split this up to a plus, and then I'm going to have my 4 and my 6. That's this 4 and 6 right here. And then here's my division. I already have that, so that's 4 and 2. So this would be a binary tree representation of this expression here, mathematical expression here. Why don't you try this one and see if you can do it, and then I'll come back. You pause this, and then I'll come back and have this done for you. Okay, some of you can do this in one go, and some of you need the multiple steps. What happens is that the last piece of information that we would do is this minus. So I put the minus first. I split it up into the x times y. So this would be my x times y, but then I know I can split that up over that multiplication symbol. So I just did that in one step. Then with this one, I have this grouping. So in that grouping, I have 4 minus, and then 7 divided by z. So the 7 divided by z would go right here, but then I'm going to divide those two, so I'm going to split that up into one more operation. I didn't write this very well, so I rewrote it with the red. But this would be your overall answer for a binary tree for this expression right here. Okay? So that's how you write that. Now, what is this getting to? Well, we're going to take this and we're going to write this in a specific order. We'll get to that, such that the computer can read it quite easily. That order is going to be a post-order listing, and we're going to use traversals to do that. Now, a traversal is that if I have A, this is B, and that's C, the traversal is right here, going across here. We don't draw that in, but the traversal is skipping over from B over to C. Now, this is how you're going to do it. You're going to start at the 8, and you're going to use the left branch, and since this is binary, you're going to have a left branch and a right branch. You're going to start with the left branch. And when you go, you're going to slide down to the left as far as you can. And so when I do that, I'm going to start at 1. So you slide down left. As far as you can. Now from here, I can't do anything else. So I'm going to go across to my partner child, except for once I get over there, oh, I slide down the ladder again. You slide down left. So you always want to slide down left. So I did a traversal, slide down left. So the next thing I'm going to be writing here is a 4. So I did a 1, I did a 4. Now what I'm going to do is from this, I can do the traversal over to my partner child, which would be 7. From 4, I can go to 7. Now once you complete the children, then you can go up to the parent of those two children. So I'm going to go to a 6. So that would be my next one. Now this is not a traversal because 6 does not have the same parent as 14. So I need to go up again. So I'm going to go up to the 3. So far I've done this first, second, third, fourth, fifth. Now, do I have a partner child with the 3? Oh, yes, I do. I have a 10. But what we do is we try to slide down. Now, this is not left. I don't have anything to go down left to, but you can imagine that I can slide over to the traversal after I've gone down left, and then I slide down more. So then my next item here is going to be a 13. So in other words, I'm really kind of doing the right branch now once I've finished the left branch. So the 13's done. Now I climb the ladder. So I get 14. And then I continue on and I get my 10. And I finish up at top with my 8. So that would be the order that I would have. So this would be what we call a post-order listing for this graph right here. Now you might want to try this one. Pause this and try this one and see if you can go. I'll start you off. The first one is an H. And then C. Pause. Okay, I'm going to try to do this quickly now. I hope you pause. So we go H, go across. So here's my I. Then I go up to my D. Then I go across to its partner child, and then I slide down to the J. I do not write that E. I just slide to the J. Then I go K. Once I've completed both children, then I can go to its parent. And then I've completed all of these. So what happens now is I can go up to B. So really I finished this whole left branch before I started on my right branch. Now I can slide over to C, but then I'll slide down here. So then this would be my L. No traversal, so I go up to my F. Now I do have a traversal. I do the G. Once I complete the children, then I can go to a parent. And then I finish up at A. So that's what you should have ended up with. All right? So I hope that you can do this. Now, what does this have to do with what we're dealing with? Well, what we're going to do now is we're going to take this and then write this using a post order listing. Then we can tell the computer how to figure out what we're talking about and what it needs to do a computation for us. So pause this and try to do the operations on number 3 here. So we start at top, slide down left, we get the A. Then we slide over, slides down, so we get the B. Get the C, multiplication, addition, slide over to the D, and then you got to go up to the top, division. So that's the order that we do have. Now this says use reverse Polish notation to evaluate these things. So when I do have my post order listing from the graphs, I guess I don't have my post order listing yet from the beginning. So let's try to do the post order listing for this thing right here now. So if I do this, I slide down, I get a 4, I get a 6, I get a plus, and then I slide over, I get an 8. Multiplication symbol, slide over, division, but then I slide down to the 4, 2, division, and then minus. This would be a post order listing for what we have. Now we want to try to evaluate this using reverse Polish notation. So that's what I'm going to show you now back on the other side. So if you had to write this in a post order listing, you would have to do the tree diagram first and then list this out. Okay, so we're going to end up with things that look like this. When we do this, and how we do this, is that we look for our first symbol when we read from left to right. The first symbol that I see is the minus. And so what we're going to do is we're going to take that operation and apply it to the 5 and the 2. So when I see this right here, first operation in the row from left to right would be the minus. I'm just going to go 5 minus 2. That would give me a 3. And I'm left with the 7 times 4, 2 plus plus. Now I'm going to go to the first operation from what I see here. That would be the multiplication. So this is what the computer has to do. It goes and tries to trigger that first operation and then applies it to the numbers that it saw just before that. So this would be a 21 because I go 7 times 3. List the 4, 2, plus, plus. You might want to underline 2-digit numbers. Otherwise, it gets a little confusing when you have that. Then the next step, go from left to right, see the first symbol, and then I'm going to do 4 plus 2 there. That would give me a 6. So right now I have a 21, 6 and a plus. Add those together, I get 27. So that's my answer. So that's the evaluation that you need to do for a reverse Polish notation. Try this one here. Go to the first symbol and apply it to the 2 previous to that. Go ahead and try that. So 7 times 2 is 14. Then I rewrite. Then my first symbol is this one right here. So I don't even use this first number. I just keep on sketching over until I see my first symbol, take the previous 2 to it, and add those together. So that would give me an 8. So I'd have 14, 8, and then a division symbol. So my result would be 14 divided by 8. Excuse me. And so those would be the answers that you would get. 14 over 8 is equal to 7/4. That's how you evaluate using reverse Polish notation. What you might have to do in the homework is take something all the way from this and complete this binary tree, then write out the post order listing, and then go ahead and evaluate it and make sure that it does turn out to be the same. All right, there's your homework. I hope that this made sense. Ask questions in class if you need them. Thanks. Have a great day.